Hello everyone, let's do Module 4, IAM, or Identity and Access Management. So let's get into our first section for Identity and Access Management, and that is, first of all, proving that identity with authentication. So with authentication, what we are trying to do is to prove identity. It's all well and good to say that you are a particular user, but until you've proven that, it's not going to do us much good for security. So what we need to do is have some good authentication. But how do we know what's good authentication? Well, first up, we're going to have secure credentials. That's going to give us confidentiality. Then, the authentication cannot be bypassed by our threat actors. That would mean the system has integrity. And there should be minimal delay or any latency involved, which means we've got some good availability going here. So, what do we normally use for authentication? Well, we've got various mechanisms, but we try to categorize our mechanisms into what we call factors. Now, it's just an arbitrarily complex name for just the category of the authentication mechanism. And our factors can either be considered single factor, where you've only got to do one thing to prove your identity, or multi-factor, where you have to do more than one thing, and the more the merrier. Later on, we'll have a good look at what is multi-factor and what is not multi-factor. Let's look at our factors. So we've got the original three, as I like to call them: the knowledge factor, the possession factor, and biometric factors. And then we've got some new kids joining the party. I call them supplemental, and that's my most generous name for them. And they are the location factor and the behavioral factor. I will tell you why I'm not overly mad about them, but they can still be very, very useful to us when we get to them. But first of all, let's break down the knowledge factor. And the knowledge factor is something only you should know. It is by far the most commonly used factor of authentication. I'll let you take a guess at why. Some examples include passwords, PIN codes that you have chosen, and answers to security questions like what is the name of your oldest cousin, stuff like that. Now, with knowledge factor, things like passwords, chosen PIN codes, and stuff like that, it is probably most commonly used for the simple reason that it's very simple to implement from a programming and system administration perspective. Many users are already experienced with passwords and PIN codes and stuff like that. And it doesn't require any extra hardware of any kind, and yeah, it's pretty straightforward. As long as the thing's got a keyboard, you can go crazy. But possession factor does bring something different to the table. Now with possession factor, it's something that only you should have. Either you can have purpose-built hardware to do this, like authentication tokens, like smart cards, key fobs, or security keys. Now with smart cards, they sort of look like modern credit cards and debit cards with that little chip in it. It can go into a smart card reader on the computer, and now that smart card could act as both a building access control card as well as a physical token for authentication. With a key fob, that will usually be something that goes on your keyring. The idea is with most key fobs that they generate a 6-digit one-time PIN for a small period of time, and that little key fob is synchronized with your account on the domain controller, or whatever is used for authentication in your environment, and it knows what PIN code will be generated when. So only you know because of that key fob, and only the server that authenticates you know. And with a security key, usually it is a hardware appliance that's plugged in, more than likely through USB, that contains something akin to a digital certificate that contains your identity. But because we now need to get specialized hardware, we also do have software authentication tokens to make our lives a little bit easier. Now, they're not as good as a dedicated piece of hardware, but hey, it's the next best thing, and it still does give you that possession factor. So one of which would be via SMS, getting a one-time PIN or something like that. Or an email code. Now, if you've ever done a password reset on certain websites, you probably experienced this. And we can also do phone calls where you've got to follow the voice prompts and push a number. Or we could do a push notification where you have to react to it on your phone. I am more inclined to push notifications than SMSs, because with SMSs there's just a few too many exploits that exist for them. Whereas with push notifications, it's a little bit more robust and secure, but I did say a little bit. And we could also use authentication apps. The authenticator apps would be things like the Microsoft Authenticator, the Google Authenticator. Basically, it generates a one-time PIN, but it uses your phone instead of you needing a hardware fob. Personally, I dig these a little bit more as long as the Authenticator app itself is kept well secured. But that is the possession factor. Now, let's look at the biometric factor. With the biometric factor, this is something that only you should be. Now, if you're thinking, but I am me. Yes, I know you are you. You know you are you. But the computer doesn't. So you need to prove it with something that is only possible with your physical attributes. The fingerprint is probably going to be the most common example and also the most straightforward thing to implement when it comes to biometric factors. Now, with fingerprint readers, please be aware they can range from incredibly simple and easy to trick, like, for example, a photocopy or a print-off of the person's finger could fool some. And it could range up in complexity and price to something that would check that the fingerprint has the conductivity of human flesh, that there is blood flowing under the skin, that there is heat emanating from within the finger, but that would be a lot more expensive, but also a lot harder to fool. And that leads us to another thing that could be used, which would be facial recognition. Now, with facial recognition, it has gone a long way in the last few years, to the point where I had an experience about 2021 where I was busy working at a client's premises and they enrolled me in their facial recognition system as a guest. And being winter, I was wearing a hat or a beanie, I can't remember, but either way, the top half of my head was covered up. And it was also during that interesting experience we had from 2020 up till 2021, 2022, COVID. And so I was wearing a face mask. It could accurately pick me up and recognize my face with just my eyes and nose showing, and it was quite quick as well. So as long as the camera is of good enough quality and the algorithm is quick and maps enough points for comparison, facial recognition is really good nowadays. It's nothing like it used to be where a person that looked like you would be good enough. It's able to do very, very good distinguishing between individuals, even blood relatives. We also have voice recognition, where it picks up on your voice. Yeah, I could have chosen better wording for that, but anyway. Now, it doesn't just listen to what you and I could hear. It also uses a sensitive microphone to pick up on some inaudible frequencies that are very consistent regardless of what happens to your voice. But the problem with voice recognition is that your voice does change throughout the day. If you listen to how my voice sounds right now versus how it's going to sound at the end of the video, you'll probably notice a slight difference in how I sound, because I'm talking quite a lot, obviously. And therefore, it would also affect the ability for voice recognition to accurately recognize you. Well, we could also try eye scanning. Now, when we do eye scanning, we could look at the retina. Now, the retina, for those of you who are not opticians, is the back of the eyeball. Wait, the back of your eyeball? Yep. So if you've ever been to an optician and they've done that little check on the health of your retina, they'll tell you to put your head up against this machine and you'll get this blinding flashing light. It is literally taking a photograph of the back of your eyeball, and it is mapping the blood vessels there. Now, those blood vessels at the back of your eyeball are as unique to you as your fingerprint is. In fact, it actually is, in a way, more unique than your fingerprint is. And that's pretty awesome. Another benefit with the retina scanner as well is it's very, very difficult to create a fake retina. And don't worry, somebody will not be pulling your eyeball out of your socket, as gruesome as that sounds, because as soon as blood flow stops, those blood vessels begin to wither and die, thus changing the pattern. However, there are a few problems with the retinal scanner. First of all, the scanner does have to make contact with your eyeball, which can give quite a few of you guys the shivers down the back of your neck, and I don't blame you. Can be a creepy thought. The reason why that's an issue for me is, first of all, there is a possibility of injury if somebody's in a rush. Second of all, there is the possibility of diseases transmitting through the tears left behind on the scanner. And lastly, that bright flashing light is not the greatest thing for people who have photosensitive epilepsy or anything like that. So, not a great idea. Then we have the iris scanner. Now, the iris scanner will focus on the pattern around the pupil, which is pretty unique, but not as unique to you as we would like. For example, like the retina. Now, with the iris scanner, it is going to run into some interesting problems, like, for example, pupil dilation can mess with it. And also, the iris does change over time. due to a variety of factors. So it's not nearly as consistent as things like the retina or the fingerprint scanner. And I would also like to introduce the cultural concern around doing an eye scan. For a lot of people and a lot of cultures and religions around the world, the eyes are the literal or metaphorical window to the soul, and trying to capture anything from the eye, even a picture, is like trying to peer into someone's soul or even stealing it. Now, if you are thinking I'm talking rubbish and I sound like a Luddite, I'm not intending to, but you must remember that technology should not come at the cost of somebody's cultural, spiritual, or individual rights. If people aren't happy with eye scanning, they're not happy with it. And it is a very expensive thing to invest in. So when you're looking at these possibilities, you're probably thinking, yeah, fingerprints and facial recognition are going to be the quickest and easiest to go with. And you're probably going to be right. Now, when you are looking at biometric factors and scanners, you do need to consider the efficacy of the scanner. Now, biometric scanners usually have two measurements of their efficacy. Biometric scanners usually have two measurements of their efficacy. First is the false rejection rate, also known as a type 1 error. Now, the false rejection rate, that is when it blocks you or denies you when it actually should have let you in. Why? Because it just didn't do the scan well enough. Now, ideally, you would like your type 1 errors to be as low as possible, but having a slight amount of people getting blocked when they should have been granted access is not a big crisis compared to the other problem, which would be the false acceptance rates or type 2 errors. This is when it lets somebody in that it shouldn't have. So remember when I mentioned that with facial recognition, if it was able to see somebody that looked a little bit like you and then would let the person in, yeah, that's a false acceptance rate or a type 2 error. And that one you obviously want as close to 0 as possible. Please. All right, but that's the original three. Now let's use some of the new kids on the block, like the location factor. So the location factor is relying on where are you to figure out whether it should trust you or not. Now, the problem is it's not as reliable as other factors because let's say, for instance, your smartphone locks up if you are not at home, not at work, and not at a usual place you go to. It remains locked down and inaccessible. Well, here's the thing. If I take your phone and I go to your workplace or go near your home, I will be able to unlock the device. So we probably want to pair this up with something that's a little bit more certain it really is you and not somebody who just happens to be in the right place. So things like, for example, location spoofing is another way to try and get around the authentication factor, because with a little bit of GPS hacking apps, you can trick the device into believing it is where it's meant to be. A good example would be if you go look at GPS hacking for Pokemon Go, that was a thing. Any sort of geolocation-based game could be tricked by the right tools into thinking it's where it's meant to be. Then, like I said, taking the items to the correct location, that is another issue. And then another thing to consider is that GPS signals are not perfect and can be interfered with. And being inside of a building or in underground parking or something like that could definitely mess with that. Also, true GPS is very, very power hungry. More often than not, something like your smartphone would probably be using geolocation, which requires the cell network and data to use reliably. And if you are like, for example, a prepaid customer, where you buy your data as and when you need to, that can get very expensive very quickly. And if you run out, that could be a bit of a problem. And even if you're not a prepaid customer, even if you're going with a contract of some kind, if you are maybe, for example, out of range of your cell provider, that's not going to do much help for you, is it now? But what location factor does help a lot with is adding some context to other authentication factors. So for instance, if I see you logging in from your home environment, so somewhere near where you live, yeah, I'll trust that. If I see you logging in from a different city, I'll be a little bit, that's unusual. Has this person traveled there? And then I'd go and check to see. Are you traveling or not? Are you on leave? What's going on here? Okay, next up is our behavior factors. So with behavior factors, this is usually something you exhibit, something that you are going to do that is unique enough. So things that are considered behavioral and unique enough are things like your style of doing your signature, not the actual visual appearance of it, but where you start, where you finish, where you cross over, all that fancy stuff. Also, typing patterns. The way you type and the types of errors you make on the keyboard and the speed you go at with certain letter combinations is somewhat unique to you due to your hand geometry and the keyboard. Now, my problem with that is if you've got a hand injury, that's definitely going to affect your typing. And also, if I give you a different keyboard, you might not be as quick and as good as you normally are with your preferred keyboard. And then, usage patterns. The way you use your machine is also kind of unique to you. Like, for example, you get some users who will close the window instead of minimizing it. So that would be an example. The problem with behaviors is they're not set in stone and they're not absolute. So, for example, somebody could decide to change their signature. Oh dear. Or somebody could get a better keyboard and start typing differently. Better or worse, it doesn't matter. So you can't rely on behaviors. The idea does make sense. People are creatures of habit, but habits can be changed. So it's not absolutely perfect. So some variance must be accounted for. And it's not as reliable as other factors again. But it can be used to add context to other authentication methods like the location one does. That is why, despite not being as absolutely certain it really is you, it still does help a bit. So let's talk about multi-factor authentication now, or MFA. Now this is something you want to definitely look at implementing in your workplace. Let's check out what it is though. So with MFA, it is 2 or more mechanisms from 2 or more factors. So worded more simply, it is 2 different mechanisms, 2 different ways of authenticating from 2 different categories of which we've just gone through. So, for instance, having a password and a one-time PIN sent to your phone, how it doesn't matter, that would be considered multi-factor. Cool. Now, word of warning, and listen very carefully, please, because I know with exams like CompTIA Security Plus, they love to try and test you on, do you understand what is and what is not multi-factor? And having multiples of the same factor is not considered MFA despite the word multiple appearing in both statements. Think about it this way. If somebody has to put in a password and a PIN code that they chose, both of those mechanisms are knowledge factor. That is not MFA. You're just asking the person to do 2 of the same thing. And think about it this way. If a user chooses a bad password, that's predictable and I could find out by just cyber stalking them on social media, I bet you their PIN code is either very badly chosen or even worse yet related to their password in some way. So for instance, if a guy chooses his girlfriend's name or wife's name as a password, he'll probably use their birth date or their anniversary date as the PIN code. Not a good thing. So that's why you must be careful with multi-factor. Multiples of the same factor doesn't do much for your security, but it does add more inconvenience to the user logging in for no discernible benefit. Yeah, I'm definitely going to make sure my multi-factor is going to give me a benefit if I'm going to get the users upset with me. Now, the benefit of multi-factor is it does drastically decrease the attacker's chance at bypassing the security, as the chance of the attacker knowing a password and having a device that only you must have, much lower than if you were relying on just one of those 2 things. So, great idea to go with. But please be aware, even if you do multi-factor authentication right, and you take 2 different methods or mechanisms from different factors, it is going to increase the user's inconvenience. And the problem with the increase in user inconvenience is when security starts interfering with a user just going about their day and getting their work done, they are likely to resist it and possibly even work against the security. So you do need to try and favor solutions and designs that have minimal inconvenience for the user, and possibly balancing that out with some convenient security like single sign-on that will be discussed later in this video. Cool. Now, let's do some password concepts. Come on, you had to have been expecting this to pop up in this course at some point, right? And we're going to run through the common attributes for passwords. The first and foremost is length. Now, conventionally, we normally recommend 8 characters. But a couple years back, the National Institute of Standards and Technology in the USA, NIST, updated their guidelines to recommend 16 characters. Wow. But here's the thing. Their updated guidelines have some interesting concepts and principles working in their favor, which I will overview once we've got through all of them. So first up, after the length, is complexity. So when talking about complexity, we're talking about uppercase letters, lowercase letters, numbers, and special characters. So there's 4 different things that could make for a complex password. Uppercase, lowercase, numbers, and special characters. And the conventional wisdom recommends 3 out of 4 complexity. Although if you want, you could try and push for 4 out of 4, but remember that user inconvenience thing we mentioned just now. Now, with the updated guidelines, we do not enforce complexity, but we do encourage it. You can actually argue that maybe doing 2 out of 4 complexity would not be a heavy enforcement because people would probably choose letters and numbers. Next up, aging of the password. After a certain number of days, the password should have to be reset and a new one chosen. Ideally, you get a policy in a domain environment to do this for you. And we normally recommend, with conventional wisdom, of 14 to 30 days. Do not go below 14 days, please, I beg of you. Years ago, I had somebody I was working with, and they asked me, what would I consider to be too frequent a password reset? And I said, anything below 14 days. He says, well, my workplace is doing password resets every day. And I'm like, wow. And then this guy goes on to tell me about all the different problems he's having at the workplace. People are writing their passwords down. Of course they're going to, because the password's only good for a day. They're not going to care about it. They're choosing bad passwords, meeting policy, but they're still bad. And again, because you don't care about your password, because you're going to have to choose another one tomorrow, you're going to see people resisting. There were even users that bought a USB mouse jiggler. Now, for those of you who don't know what that is, it's a little device that looks like a flash drive, and it just moves your mouse by 1 pixel every couple seconds to stop a screensaver and the subsequent lock screen from kicking in. So if you do want to have regular password resets, just be careful about going below 14 days. You're going to annoy somebody at some point. Now, the updated guidelines recommend no expiration, but a universal, in other words, organizational-wide, reset if there is an account breach anywhere. And the thing is, you don't want to be that person that causes everybody to have to choose a new 16-character password, now do you? I could do some evil voiceovers, I think. Anyway, next up, reuse should not be allowed in either conventional or updated guidelines. And to help enforce people not reusing their password, we have password history, and we recommend at least a year's worth of passwords, although I normally suggest something just over a year, so that people don't have a January password, a February password, a March password, etc. But with the updated guidelines from NIST, keep that history going for as long as possible. Now, a little bit of exam advice before we get carried away here. Exams like CompTIA's SY0-701 focus mostly on the conventional password policies. However, you might want to consider maybe, if your organization's culture could handle it, the updated guidelines. So, why is the new updated guidelines so very different and against conventional wisdom? Well, first of all, really long password, right? But having 16 characters does drastically increase the number of possibilities that the password could be, which makes brute forces a lot more difficult to achieve. And believe you me, many of you users will go for the bare minimum number of characters they need to go for. Complexity has been part of password policies and workplace culture for a long time, so people are already doing semi-complex passwords. They're at least doing 2 out of 3 complexity. And when people find out their password is not going to expire, they're going to put more thought and effort into a good password, especially when they might be the guilty person who causes everyone to have to choose a new one. They're really going to put some effort in there. Nobody likes being singled out, especially when everybody's going to be upset with you. Then, reusing a password, yeah, we're pretty good with that one. And obviously, because we're going to have passwords being used for a long time, the history should be as long as possible. So that's the generalized password concepts. But I might, if I listen very carefully, hear some of you guys saying, but what about password managers? Well, let's talk about those now. So password managers are utilities that will remember your passwords for you, help you generate good ones, and maybe even enter your password into websites and applications that you're busy accessing. Now, a password manager can either be an operating system or browser utility that is part and parcel of the software you're using, or you might be using a third-party one. I'm not going to name drop any because I haven't got any partnership deals or affiliate programs going on with any of them yet. Anyway, now the great thing about password managers is it does allow users to have longer, more randomized passwords, especially if the password manager is generating the password for them. Much better than what the user can handle on their own. But there are some catches here. First up, the application itself might be vulnerable. Not a great thing. And third-party vendors, when it comes to being a password manager, are very frequently targeted by attackers and could potentially become a point of compromise if they are centralizing password storage. And if you take a step back and think about it, with a password manager, yes, they can be password protected, but that's one key protecting all the other keys to your home. Might be better just to try and remember a handful of different passwords. Honestly, there's no right answer, there's no wrong answer here. It can be useful. If you've got users with very bad password practices, then a password manager might help alleviate those problems, where you are sadly choosing the lesser of two evils. And the reason why I say sadly is I hate having to choose between two evils. But sometimes you're forced to, I'm afraid. But that is the basics of the authentication. Now let's talk about what we can do with that authentication. Managing how people access things. So when it comes to that, we have got the following access control models to work with. The first one is something called mandatory access control, or MAC. Now, if you're thinking, hang on, that's like saying a MAC address for media access control and networking. Yeah, another useful tip when it comes to IT in general and security exams specifically. Use context clues. If the exam, for example, or the people are talking about networking and they say MAC, they're more than likely referring to the MAC address of your network card. When they're talking about security, especially access control, they're most likely talking about mandatory access control. So, clues in the context. So, after mandatory access control, we have discretionary access control, or DAC. But don't worry, I've got more than two choices for you. We also have role-based access control. Please don't abbreviate that to RBAC because you might confuse people with rule-based access control. Oh dear. Yeah, you can see why I don't want to abbreviate that to RBAC. Then we also have attribute-based access control. And if you really want to, you could abbreviate that to ABAC. But, your choice. Now, let's run through each of them and discuss what they entail. So, first up, mandatory access control. What happens here? We use security levels with clearances. And we take our resources, usually data, we label them for whatever clearance is required. That clearance level must be met at the very least, or better yet, exceeded. And then what will happen then is users get granted a security access level. And as long as their level matches or exceeds the resources label, they're good to go. Now, the problem with mandatory access control is it can be very, very restrictive and not very dynamic. But it does work amazingly well for security, especially when it's implemented well and it gets reviewed regularly to ensure the resources have the correct labels and the users have the correct security levels. But sometimes things will go wrong where maybe a user is approved to have a higher security level, but IT does not get notified, and then when the user does try to access that resource, they run into problems. Is this microphone moving? That's fine. Just an illusion. All right. Another problem with the restrictions is, like I said, it does affect collaboration and definitely takes away user autonomy. However, in an environment where security is paramount above everything else, this might be necessary. And in situations where security is really important and user behavior cannot be trusted, this might be necessary. Now let's go to the opposite end of the spectrum when it comes to strictness. Discretionary access control. So discretionary access control, the resource owners or the data owners control who may access their resources. Now this is taking advantage of conventional file system behavior in both Windows and Linux. So what will happen here is this. When you create a new file, a resource, you are usually the owner of said file. And this is going to now rely on the owner to apply the appropriate access controls to the data. And like I said, this is the default for Windows and Unix or Linux-based systems. This gives us the most flexibility as people can decide who gets to access their data and how. But it can be very difficult to centralize and enforce good security effectively. And it is prone to what I like to call the everyone full control weakness. If you have ever done a shared folder in Windows, The quickest and easiest way to get anyone accessing it is to share it with the everyone group, and as long as you are somebody using Windows, you fall into that. Even if you're not part of the domain in an organization, you are part of the everyone group. And then full control, you can do almost as much as the owner does. And a lot of users will find if they apply that setting, then stuff just works. That's fine for them. Remember, users are paid to get their jobs done, not to implement security. Unless they are paid to implement security, in which case that's their job, and then I'm talking to you. Yeah, anyway, overanalyzing that. So you're going to have to be very trusting that your users are very security conscious and understand the implication. The problem is, though, you just need one person. Just one person to make a bad choice here. Okay, so if discretionary access control is too flexible and mandatory access control is too strict, do we have anything else that we could work with? You betcha. So with role-based access control, system admins define roles, and they'll grant roles access rights to the resources. Remember the data stuff that we're trying to access. Then the users will be given access to the roles and can then assume the role and the access rights when appropriate. Now, the nice thing as well here is users can have multiple roles, and the most appropriate one will be used when they're trying to access a resource. So, for example, you might be in the IT support group and the security group. And if you're accessing a resource that only IT support has access to, that group membership you have would be used. Whereas if you're trying to access something that only the security personnel access, then that would be the group you would be using to gain access to it. Sorry if I didn't mention that before. Groups or security groups are one of the best ways to implement access control. And it does offer a good balance of security and flexibility, and we're not relying on the users to have to make a good choice here. Not bad. But you've got to be careful, because if not done right, this can lead to too many roles to handle edge cases. So for example, you might have a sales group and a managers group. But then what about the sales manager? Are you going to go create a group specially for them? No. If you have something where the two groups are giving a problem, you'd rather give access to the specific user to handle edge cases. You have to be careful not to create too many roles, otherwise you're going to get paralyzed by having to figure out which user needs access to which role. But if you really want to go crazy with lots of config and setup to have fine control over what type of flexibility and security you have, rule-based access control might be for you. This is where the system enforces a set of rules that is usually configured by an administrator, and it uses conditions to determine if access should be granted or not. And the conditions are the things that we get to have our fine control over. The conditions can be inspected continually as well, and access could be taken away if the conditions stop being met after having initially been granted. That could be very, very useful to us. And as I said already, this does give us a lot of fine control over what is and is not going to be accessible. However, you've got to be a bit cautious here as well, because the rules can become long and convoluted. You've got to very carefully plan the rules out, discuss things, work it out as a team, figure out the problems and stuff like that. And you also do have the risk of rules conflicting with one another. And a bit of advice when it comes to cybersecurity. Anytime there is a conflict in cybersecurity and a system needs to figure out what's the right choice to make, it'll usually default to the more restrictive choice for security's sake. So be aware of that. That's why you've got to be very careful with your rule management. This is one of the reasons why firewall engineering or firewall engineers is actually a job title, or at least a firewall technician if the term engineer is a protected job title. Either way, it's the reason why there are people that specialize in managing firewalls, because rule management is a fine art with a bit of science mixed in as well. And then for a fairly new thing, which is actually quite refreshing and awesome because it's kind of a good middle ground for everything. Attribute-based access control. It gives us the finest level of control, and we can also not have to worry about going too crazy with specific rules, because what happens is attributes are inspected. Now, the attributes that can be inspected could be the user, sometimes referred to in this access control model discussion as the subject, the resource or the object that the person is accessing, usually data, but it might be an application or a service, It could also be system-wide attributes, like, for example, time of day, operating system update level, stuff like that. And any other contextual information, like location and behavior, all of which are super useful to look at. And the attributes can be combined in various ways, and then the combination of attributes will be used to decide whether you get access or not, which I think is really cool. And it can be a lot easier to configure attribute-based access control compared to things like rule-based, while still giving us a very fine degree of control. However, you do need to be careful, and you do need to review and test. Otherwise, you might have some unexpected results from the attributes being applied. Cool. Now, let's talk about something you always want to do when deciding what level of access and privilege you want to give your users. The principle of least privilege. So the idea of the principle of least privilege is that you are going to give your users exactly the rights, the access, the permissions, etc. to do their jobs, and not a single bit more. Now, this will require continual implementation. You'll have to do this all of the time. When you're dealing with new hires, when you're dealing with people that are already working there, but have now got a new job role, or when projects change and new access needs to be granted. You will be applying principle of least privilege in all of those cases. And on your first round of implementation, if this has not already been done in the workplace, you're going to have to review all existing access rights as well. In fact, it would probably be a good idea if you just did this continual review anyway. Now, you are going to experience some horrible implementation challenges. People are going to resist this. You're going to have people, especially in senior positions or positions of power, that think that they are entitled to more access rights and privileges than they actually need. For instance, a project manager in charge of a bunch of developers will want to know why they are not getting the same level of access their developers are despite managing them. Well, it's because the job role they have doesn't dictate and require admin access to test things or to develop software. Whereas the people working under them, they do need more access to their systems so that they can actually develop the applications that the organization is trying to build. So, yeah, you're going to have some interesting challenges with people in power, especially in the middle of the organizations where you're most likely to get people on a power trip. Anyway, but the benefit of doing principle of least privilege is it does decrease the risk of what could be done if a user account is ever compromised. So definitely worth looking at doing. Another thing as well, seeing as we're talking about principle of least privilege, is to talk about the provisioning of user accounts, how we go about creating the user accounts and allocating the access rights for them. Now, obviously, I can't tell you exactly what needs to be done, as I don't work with you at your workplace. However, you and HR will probably have to collaborate on this. And if your organization does have some governance should be overseeing this to ensure that the collaboration is taking place and that policies are actually being enforced and the procedures are being followed. If, however, you have not got policies and procedures for provisioning of a user account, this is a great time to start thinking about implementing these policies and procedures. So when you create them, obviously you're going to have to think through the scenario of what would be the most sensible way to create a new user account. But these policies will probably not be right on the first go. Fun fact, policies are living documents. So continual refinement should be done and should not be shied away from. Ideally, you want to work ahead of the user's starting date or first date of work, so that when the user does arrive on that first day, it's as simple as unlocking or enabling their account. Fantastic. But what kind of process could you look at following? Well, here's a general one that you could look at using. First up, validate the new user's identity. Just to be sure you're adding the correct details, that you're spelling the name right, stuff like that, and that you know you're adding a real human being and not somebody trying to impersonate a staff member to gain access to the workplace. Now, ideally, any red flags should have been dealt with during the interview and hiring process by HR, which is why IT should get involved in HR's hiring process and policies so that we look for those suspicious red flags. Like somebody looking for a janitorial or cleaning job after having studied but not completed some sort of computer science or technology related qualification at a tertiary level. That would be a red flag for me. But hey, I know the job market can be tough out there. Then we would issue credentials. And when we do issue credentials like the username, password, etc., we must make sure that if it's anything that's a knowledge factor, that stuff is a forced reset. So that the first time they log in, they have to choose a new password. Because if they get to carry on with a password and that administrator set for them initially, now we've kind of undone the whole thing about knowledge factor, which is something that only you should know. And if somebody else knows it, well, technically it's not that effective. Then asset allocation should take place, and that should be documented. So when they get issued with a laptop, for example, we keep track of the make, the model, the serial number, all of that stuff. And obviously, that information is meant to be kept and updated as needed. We should also give the person any policies that are essential and required for them in the workplace, like an acceptable use policy, dress code, stuff like that. And they should also receive some kind of training to guarantee that they are, to some extent, aware of the policy. Whether that training be conducted by a live instructor or pre-recorded, it doesn't make much difference as long as it was put in front of them and they had to engage with it in some way. And then permissions will be assigned to them once all those boxes have been checked. You might have thought, wouldn't that be done ahead of time? Well, you can assign them, but not enable them. And when you are doing this, please adhere to the principle of least privilege. But we can't always look at the positive, new people starting. What about people leaving? We have to deprovision user accounts when people leave the workplace. So again, policy and procedure kick in. If you haven't got it, create it and refine it. And think through various scenarios of an employee leaving the workplace. Scenarios like their resignation, their retrenchment possibly, dismissal, it's a nice way of saying you got fired, contract expiring if they were a contract worker, or retirement, and even death. So you've got to think through those different scenarios. With resignation, retrenchment, dismissal, and contract resignation, you do have to consider the employee is possibly going to come back. Retirement, less likely. Depends on the organization and how they handle the retired person. Death, they are unlikely to come back unless we get some zombies, in which case I think the least of your problems is deprovisioning a user account. But one big piece of advice, do not trust anybody who doesn't seem to be in a bad mood or seems pretty chilled with some experience. There have been many a case where somebody got dismissed. They seemed pretty okay and chilled with the whole situation. And then on their way out, they cause some trouble. Remember, acting is a thing, and you'd be amazed how well some people can act in the workplace. So don't trust minimal behavior. Make sure that you are very carefully monitoring that user account before they are leaving the workplace. In fact, it might even be a good idea that you don't make a user, especially a user in a sensitive or a privileged position, work off a notice period or a dismissal period. Pay them for that period, obviously, so that you're legally okay, but don't make them work because that gives them opportunity to do something on the way out. Now, a very useful process to follow for deprovisioning a user account. Back up and document any settings and details to do with that account. You would be amazed how useful that can be, especially if you follow my guidelines, which I'm going to bring up now. But once you've documented all the settings, access rights, etc., you remove them so that that account cannot gain access to those things anymore. The reason why you want to document is in case you ever need to re-enable that account. Maybe the person comes back, maybe they had access to something that nobody else has access to, and you need to re-enable that account to sort that out. Well, by having documented those settings and access rights, you will be able to recreate that user account more or less as it was before. Then reset any credentials for that account so that the person who had the account can't use that password because guess what? It's not that password anymore. Ooh. You can also deactivate the account to prevent it from being used for login. And if you are worried about this deactivated account taking up space, well, then you can just make sure you back up and archive any data files tied to it. because the user account itself is going to take up a few kilobytes of storage. And if you're worrying about a few kilobytes of storage on your authentication server, you've got bigger problems than this. And my personal advice to you is this: do not delete a user account even if they've died. It might be impossible to recreate that account in the future, even if you've backed up all the settings and recorded all of that. With operating systems like Microsoft Windows, the user ID and the security IDs assigned to the user are one-time IDs. Once used, they will never be reused by your system. And resetting them manually is difficult, nigh on impossible in a lot of cases. If you're dealing with a Linux-based system, you're a little bit more lucky because there you get to manage user ID and group ID numbers manually, which is great, but not universal. So please, rather just leave the user account and do all of that removal of the access rights, deactivation, and resetting of credentials. You'll have a way easier time of it. You could consider deleting the account after a sufficient period of time has passed, because probably after like 3-4 years, if you haven't needed that user account, you probably never would. Now, let's talk about attributes and policy enforcement. So, what attributes could we look at for ABAC and other similar access control mechanisms? Well, user ID, security IDs, group IDs, credentials, etc. We could also look at applications and data types as attributes. Pretty much any uniquely identifiable thing within an organization's IT systems could be considered an attribute. Then we can combine those attributes together, create some policies, and enforce them. Those policy enforcements could either be local rules on resources or, better yet, enforced through a domain where pretty much every system that's part of that domain will obey the policies. Usually a protocol service like the Lightweight Directory Access Protocol is ideal for this. Better yet though, rather use LDAP-S, because at least then it's got SSL TLS encryption going for it. And technologies like Microsoft's Active Directory or OpenLDAP for Linux is a great option for this. Now, another cool thing we could look at doing for managing access would be to do some account usage restrictions. So we could restrict what the user can do or whether the user can even log in based on things like their location. And in terms of location tracking, we could use the IP network if they're on the LAN, to maybe restrict them if they're on the wireless, or give them better access if they're on the wired, or if they're in the wrong department or area of the organization. We could also use geographic location, which could be derived from either their GPS signal, geolocation services, or something called GeoIP, where we try to keep track of which IP addresses have been allocated around the world and use that to determine yes, they're in the right place or no, they're not. And then we could also look at time-based restrictions, where we could, for example, have logon times. Now, logon times could be, for example, when the user account can log in and after which time of the day they cannot be logged in any further. I always feel bad because I feel like I victimize this particular type of user, but receptionists are a great example of a group of users that could have logon time restrictions applied. Because I don't expect a receptionist to be at the workplace much more than an hour or two before the building opens to the public. And I don't expect that receptionist to stay at work much more than an hour or two after the building closes to the public that day. So any time after the closure, like let's say if the building closes at 5 p.m. and somebody's trying to log in at 10 p.m. with the receptionist account, that should be a massive red flag, or better yet, block it rather. Because what receptionist is trying to log in to work at 10 p.m.? Yeah, I'm sure there's going to be some exceptional cases out there that people can argue for. But the thing is, we can't handle every edge case. In general, it's going to be more suspicious and should probably be prevented. And whatever the receptionist does need to do at 10 p.m. could probably be done at 6 or 7 p.m. in the morning. So that could be a useful way to limit it. But I know not every group of users can be subject to such a strict schedule. So another thing we could look at doing is a logon duration, where you enforce how long that user account may be logged in for. I don't expect people to work much more than 8 hours a day on average, 10, 12, maybe 14 hours tops, unless you're working in a really toxic workplace, in which case, yeah, I don't know what to advise you on then. but login restrictions can be pretty cool. Another trick as well is to combine time and location to track for impossible travel. The idea is you would not be able to get from, let's say, Brazil to Belgium in half an hour. That's not possible. So if suddenly the login takes place in Belgium half an hour after a login in Brazil, one of those two is not legit. Which one? I don't know. But something we might want to look into. Very good idea to implement some sort of impossible travel. Another cool thing that can be done as well is giving time-based temporary permissions. So for example, somebody might need escalated privileges for dealing with a disaster. Cool. So we might give them escalated privileges and permissions for maybe the next 48 hours or something like that, so that they can perform more advanced tasks, but once that time has passed, then they're back to where they used to be. That way you don't have to keep reviewing for principal of least privilege. So that's going to help you out a little bit there. Now, let's talk about PAM. No, not that PAM. Privileged Access Management. So Privileged Access Management, you're looking at accounts that either have system-wide access or, more importantly, are administratively able. So basically, if you're an admin user, either local, domain, forest-wide, whatever, it doesn't matter, you have the ability to change settings. You are considered a privileged account and have privileged access to your systems. So we need to develop some policies around our admin users, such as making sure that they only gain access rights for administrative capability temporarily. So for example, things like Linux's sudo command only works for a small period of time before you have to redo the password. Microsoft's user account control is also another nice example of this. Or we could look at using password vaults, where the admin has a password they call upon, but they don't actually type in the administrative password, they type in a lower password, which grants access to the application or activity to access the admin password to do the better operation. We could also look at ephemeral credentials, which are unpredictable. You can consider this to be a localized implementation of PFS, or perfect forward secrecy. Or you could try one of my personal favorite things, dual accounts. So with dual accounts, what happens is an administrator will get an administrative user account that they should only log in and use when they need. And then they get another user account, which is a standard user. And that just needs to have access to any reporting or logging utilities that they would use throughout their daily activity. And the idea is day to day, they'll probably spend most of the time using their standard user account. And only when necessary will they sign in or switch user to their admin account. And once they're done with their admin activity, they should log out of that and carry on using their standard user account. And this can be made to work with things like temporary elevation, which is a pretty good idea. But now that we've spoken about managing access, let's talk about managing identity and tying it all together. So first up, facilitating authentication throughout an organization. You could look at using local user accounts, network authentication, or remote authentication. Now, with local, that would be where the user account exists only on that computer. And with network, that would be where you've got an authentication server of some kind. And with remote authentication, you are looking at where the authentication is taking place off-site, like, for example, an identity provider in the cloud. So what do we have for Windows? Well, Windows, we've got the local user account, which Microsoft is slowly but surely trying to strangle off right now. I've been watching this take place more and more since Windows 8 came out. Yeah, I'm showing my age there a little bit, aren't I? But Windows 10, Windows 11, they've been trying to push you to using something else besides the local user account. And I'm pretty sure that at some point Microsoft is going to outright prevent us from using local user accounts in the future. We'll see what happens though. It'll be interesting to see. Or we could have network login, where we use either a Kerberos authentication or a new technology LAN management or NTLM authentication. Fun fact, we generally favor Kerberos right now, which we'll be having a closer look at momentarily. And then you've got the Microsoft account that you can sign into with a modern version of Windows. So cool, that would be your remote option for Microsoft. Then with Linux, you have a local user account, which will usually be kept under the etc passwd file. So etc being the directory, passwd being the file. And despite the name sounding like password, we don't keep the password there anymore. We keep all the other user details there though. The password itself is actually kept under etc shadow. Okay, cool. Or you could use a pluggable authentication module or a PAM. Again, no PAM, not now. Or we could use network login, such as OpenLDAP. And don't worry, with OpenLDAP, you can implement LDAP-S, so don't worry about the security of the actual protocol. You can do the secure alternative here. It just does require a bit more setup. So let's look at the directory services for a domain environment. Our directory services help us out a hell of a lot, especially when it follows the X500 standard and uses the lightweight directory access protocol, because it makes it pretty universal then. And what a directory service is basically a database of subjects, objects, and resources. And usually we identify them as users, computers, groups, roles, services, etc. Now the great thing is, as long as computers are part of the domain, they can receive information from the domain controller, from the directory service running on it, or they can send information to it. And this would allow us to have a much easier time of things. User accounts would be available on any computer that's part of the domain, as long as it can contact and validate the account with the domain controller. And any policies implemented for access control and security can trickle through to the computers and the users throughout. So that's a nice thing. And we can use access control lists to manage the authorization within them. Now, some good examples. You've got Microsoft's Active Directory, as I've mentioned a few times already, and Linux's OpenLDAP. Cool. And there are entire courses on this. One of my good friends, Burning Ice Tech, he is currently doing some pretty cool courses for the Microsoft side of things. So go check him out if you want to go and find out a bit more about that kind of thing. But for now, let's move along to single sign-on. So single sign-on, or SSO, is a convenience benefit that I encourage. I'll explain as we get to the point though. So the idea of single sign-on is you authenticate once and you are authorized to access something more than once. And this can be very useful as it balances the inconvenience of things like multi-factor authentication with the flexibility of I only need to go through that multi-factor authentication once a day. After that, everything I need to access is accessible. Now you might think, isn't that a bit dangerous? Well, first of all, you can impose time limits for single sign-on so that the account can't be signed in forever and ever, amen. Usually a standard workday is a pretty good time limit for single sign-on. And also, not every user has to have everything working with single sign-on. Like, for instance, if a user is accessing something very sensitive, you could still require a separate authentication. So imagine this. A database administrator logs into their computer. They don't have to sign into their email. They don't have to sign into Teams or whatever meeting and instant messaging tool they're using. They don't have to sign into their employee self-service stuff. That makes sense. But when they want to access something to administrate the database, then they have to authenticate again. That makes sense. So you can balance the ease of use and ease of access that single sign-on offers with security requirements for more sensitive things. It is doable. So all that stuff about single sign-on being said, let's look at Kerberos. It's created by MIT, but it's licensed by Microsoft, and they use it in Active Directory. And Kerberos does single sign-on as a 3-step process that we're going to go and check out now. So what happens is we've got the client, or officially known as the principal. We have the domain controller that's running Microsoft Active Directory, known as the Kerberos domain controller. And then we're going to have the application server, the thing that the client wants to access, whether it be an email or the employee self-service or something like that. So the first step is the user will do a logon request. This is where the client computer sends through the user's credentials and any authentication information that is needed. We are going to assume the authentication was successful, in which case the domain controller sends an approval message with something called a ticket granting ticket. I don't make these names up, I promise. Now, once that's happened, the client has that ticket granting ticket. They will then make a service request to the domain controller with the ticket granting ticket. What the service request does is it sort of acts like a little letter that says what the client may have access to. and that service ticket then gets allocated based on what access rights and authorizations that user has within that domain controller's schema. And then, once they've got that service ticket, the client can make an application access request with that service ticket. Now, if the app server is suspicious, okay, it's not really suspicious, it'll just be set up to do this. It can do a service ticket query with the domain controller saying, hey, can I trust this thing or not? And if it can be trusted, obviously it'll be told so. But if it's okay with the service ticket, it doesn't have to do that query in orange there. Another thing as well is it could do a two-way authentication, asking that the service ticket be validated with the ticket granting ticket, and the app server could then prove itself to the client and authenticate to the client with something like a certificate service. But that's an optional step, doesn't have to be done, but it would be a good idea. And then data transfer can take place. So reviewing that, you get that logon request and that ticket granting ticket, you get a service ticket, and then you attempt application access. So those are your three main steps. Ticket granting ticket, service ticket, application access request. So you can see where Kerberos gets its name from. Now, another interesting thing that can be done for managing identity and access is federation. And this is likely to take place in larger organizations where you need an account to be recognized and usable outside of the domain in which it exists. You'll see this used in a couple of interesting situations. Normally between organizations that have some sort of partnership, like a supplier and a customer, or inside of a conglomerate or a large corporation that is made up of many smaller businesses and companies. And you might have even seen this between online services where you could sign into one web page by using an account from another. This is federation. But it sounds a bit weird. How could I have an account working outside of the domain in which it exists? Let's have a diagram. So first up, let's have domain A. And we're going to have a user in domain A. Let's call him Bob. If there's any Bobs watching, I'm really sorry. I keep picking on you. And then we're going to have domain B. Now, the relationship between the two domains, they could be partners, they could be supplier and customer, or they could be two businesses within a larger corporation or conglomerate. I'm not too fazed about what it is. I'll let you pick whichever one you like. And what we're going to do is we're going to implement a federation service between the two. And the idea is the federation service will allow Bob, with his Bob at domain A user account, to go onto a computer in domain B and sign in with his account that belongs in domain A. He doesn't magically have an account in domain B. He doesn't have a Bob at domain B user identity at all. He is being federated between the two domains, where anything in domain B could ask the federation service, hey, does Bob at domain A really exist? And the federation services will find out, yes, he does, or even better yet, have that information local. All right, so let's talk about the direction of federation. A little bit of a shift in the diagram there. And we can federate in one direction. So I can federate from domain A through the federation service to domain B. That would probably be very useful if Bob needs to work on domain B and have maybe a differing level of access. Almost forgot to mention that. When Bob works in another domain, when he's federated into that domain, he doesn't necessarily have to always get the same level of access. So in domain A, Bob could be an admin, but in domain B, Bob could be just a standard user. So that's pretty cool. Or it could go the other way. You could have federation from B down to A. So maybe, for example, domain B acquires domain A. Company B purchases company A. In which case, then you're probably going to have some management and auditors coming along to make sure everything's hunky-dory and legit. So you can federate in that direction as well. Or, better yet, you could federate in both directions, where users in domain B can work on systems in domain A, and users in domain A could work in systems in domain B. It's pretty cool. But wait, what if we're looking at that online federation? So like sometimes you'll see on websites where you need an account to do something and you click sign up, and you can either create an account with an email address, password, the usual stuff, or you'll get those options to sign in with your Google account or your Facebook account or your X account, whatever. And how does that work? Well, usually that runs through something called SAML, or the Security Assertions Markup Language. This is actually a very cool thing because it is an open standard for transmission of assertion claims for identity and access rights. And what happens is it's used between organizations and cloud providers and even online entities like Facebook and Google and other websites. Now, what makes SAML pretty interesting is it's XML based, which means once you get used to XML syntax, SAML is actually very easy to work with, especially in its raw form. Don't worry, even though it's XML, which you might think is a little bit risky, its transmission is handled securely. And besides that, it's also got some internal controls that make SAML relatively robust and stable. But the important thing really is when it comes to federation is how secure is the transmission of the federated data. Well, here we have either transmission through HTTPS. It will not work through HTTP. It only works through HTTPS. So that's a bit of a relief there, right? Or we could do it with SOAP, the Simple Object Access Protocol, which is another cool, pretty good option there. Now, with SOAP, it is a specialized protocol based off of HTTPS and the REST protocol, and is only able to transmit SAML, and is pretty good at confidentiality and integrity validation of transmissions. So that's pretty awesome. But that is all we have to deal with for this module. So thanks for listening, guys. I really appreciate it. And if you haven't already subscribed, liked, shared, etc., please do so. I really do appreciate it. And I will catch you in the next module.